So let's say you are seated peacefully in the exam, minding your own business, and they decide to ask you a situation like this one. It says trolley X of mass 1.2 kg travels at 8 meters per second east and collides with trolley Y of mass 0.5 kg, which is initially at rest. Ignore all frictional effects, meaning this is an isolated system. The velocity time graph below shows the velocity of trolley X before, during, and after the collision with trolley Y. So here we can see from 20 seconds to 20.1 seconds, it's before the collision, and trolley X was moving at 8 meters per second. But from 20.1 to 20.2 seconds, this is during the collision. And we can see that the contact time is 0.1 seconds. If you find the difference between 20.2 and 20.1. Right. Then from 20.2 seconds up until it's after the collision and trolley X is moving at a velocity of 4 meters per second. Right. Then the first question says, state the principle of conservation of linear momentum. So we are not going to do that because you can do that. Then the next one says, calculate the magnitude of the velocity of trolley Y immediately after the collision. So here we are going to use the principle we stated in the first question. So we tell them that the total linear momentum before the collision equals the total linear momentum after the collision. But what is this total linear momentum before? So we say it's the mass of trolley X times the initial velocity of trolley X plus the mass of trolley Y times the initial velocity of trolley Y. And everything is equal to the mass of trolley X times the final velocity of trolley X plus the mass of trolley Y times the final velocity of trolley Y. So they said to us the mass of trolley X is 1.2 kilograms. It was moving with an initial velocity of 8 meters per second. So I choose to say it's positive 8. Well, it's not really a choice in this case, because if we look at the graph is above the time axis, meaning the velocity is positive. So the direction is actually chosen for us in this case. They're saying anything that goes to the east is positive. Fine. But for this part, we don't need to substitute anything. We can simply say 0 because they told us trolley Y is initially at rest. So rest meaning initial velocity is 0. If the initial velocity is 0, then the initial momentum will subsequently be 0. Fine. Now the mass of trolley X is still 1.2 kg, but the final velocity has decreased to 4 meters per second, but it's still moving to the east. And then we say the mass of trolley Y is 0.5. We are looking for the final velocity of trolley Y. Then from this point, I take this part and take it to the left so that it becomes negative. So on my calculator, I'm going to substitute 1.2 times 8 minus 1.2 times 4. And this is going to give me 4.8. So everything is equal to 0.5 times VYF. Then from this point, I divide both sides. by 0.5. So then the final velocity of trolley Y will just be 9.6 meters per second. This is that. So we don't give direction because the question asked for the magnitude, only the size. Fine. Then let's see the next question. Well, it says, calculate the magnitude of the average net force that trolley X exerts on trolley Y during the collision. So in other words, the force that is acting on trolley Y. So meaning we are going to use Newton's second law in terms of momentum. So we say the net force acting on trolley Y is equal to the rate of change in momentum of trolley Y. So here we have to find the change in momentum for trolley Y because the net force is acting on trolley Y. Fine. So this is the first way of writing this formula. If you like, you can say this is how I choose to write the change in momentum. But if you are still not satisfied, you can say where I see the change in velocity, I understand that it's the final velocity minus the initial velocity. So it's up to you. But you have to write one of these three. You can write all of them, but remember, it's just one formula. Fine. So we come back and say, okay, the mass of trolley Y is 0.5. The final velocity, we just calculated, it's 9.6. But initially it was at rest. So it's 0. Now regarding the time, you can choose to say 0.1, meaning you calculated the difference already. Or you can choose to show us it's 20.2 minus 20.1. It's up to you what you choose. But the important thing is it will still give you 0.1 anyway. Fine. And then when you substitute everything into your calculator, let's see how much you get. So you find that the net force acting on trolley Y, it's just going to be 48 newtons. So you don't need to start by saying, what is 0.5 times 9.6? You get that answer, then you divide it by 0.1. You can do that if you like, but it's not really necessary. Remember, this is not mathematics, this is physical sciences. So we mark the formula, the substitution, and the answer, not necessarily the steps. But if you feel you are going to make mistakes, if you omit the steps, then you are more than allowed to do everything. And guys, remember, you could have done this using the normal F net equals MA, right? But in order for you to do so, you'll have to start by calculating the acceleration. And in order for you to calculate acceleration, you have to use equations of motion, any one of those four. So imagine, you start by using an equation of motion, then you get your acceleration. Only then will you come and say F net equals MA. So it's honestly a long process, which is not necessary anyway, seeing how this is 3 marks. So if there's a possibility of taking the shortest route possible, then so be it. You only have 3 hours, by the way, and you have to finish in the specified amount. So learn to be effective in the exam. Now the last question says, is the collision elastic or inelastic? Explain the answer by means of suitable calculations. So in the previous video, when we defined an elastic collision, we said in simple language, it's where the total kinetic energy before the collision equals the total kinetic energy after the collision. But if the two total kinetic energies are not equal, it's an inelastic collision. So how do we approach this one? We have to calculate the total kinetic energy before the collision and also after the collision. Then we compare the two kinetic energies. That's what we have to do. So let's go. So we say, let's find the total kinetic energy before the collision. So kinetic energy, we know that it's half mv squared, right? So we tell them we take the mass of trolley X, we times it by the initial velocity of trolley X, which is squared. Then we say plus half times the mass of Y times the velocity of Y, initial, and then we square this. So we said the mass of trolley X is 1.2 kg. The initial velocity is 8 meters per second. So because the initial velocity for trolley Y is 0, then it means the kinetic energy will also be 0. So let's see how much we get when we type this into the calculator. Well, for this one, we find that it's going to be 38.4 joules. Then next, we calculate the total kinetic energy after the collision. So we say half the mass of trolley X times by the final velocity of trolley X. Then we square this. Now we have to specify it's VXF, right? Then we say plus half times the mass of trolley Y times the velocity of trolley Y final, which is squared as well. So the mass is still 1.2, but the final velocity for trolley X is 2. And then you say for trolley Y, the mass is 0.5, but the final velocity is 9.6 meters per second. So if you type everything into your calculator, let's see how much you get. So you get 32.64 joules. Well, of course, you'll write your equal signs there. I don't like writing equal signs, only if it's an equation. All right, then what do you do from this point? You compare the total kinetic energy before the collision to the total kinetic energy after the collision. Well, you can see that they are not equal. So you can use this symbol, or you can say the total kinetic energy before is greater than that after the collision. Then your conclusion will be, therefore, this is an inelastic collision. So if maybe they asked you, what happened to some of the kinetic energy? Well, you'll tell them it was converted to heat or to sound when the two trolleys were colliding. We can also have other forms of energy, but the most common ones would be these two. And this would bring us to the end of this video. Thank you so much for watching.